All right, so we're doing value problems. This is officially recording at this point. This is coming live and direct from the studio, round 2, aka US 206, aka Somerville's classroom, aka what's up, Adam Altman over there? There's my boy. We have already started, Kitty. Way to go. All right, so we're talking about value problems. The only difference between a value problem and the problems that we've been doing before is that we have a value, a specific number that is associated with the variables that we choose. Okay? So one thing that we like to talk about in value problems, value generally goes with money. Okay? So if I said something like, Dante has 7 coins in his pocket. Quarters and pennies only. And then I'll actually tell you how much money Dante has after that. I'll say something like, Dante has, you know what, I'm going to go with a 55 cents. How many of each coin does he have? So I see the wheels turning in the back row already. Chris is like, well, a quarter's 25 cents and a penny is worth 10 cents. So I know, I was kidding. I was imitating Chris, you know. Chris, the wheels were turning, but there was nobody on the tricycle, you know. All right, Dante has 7 coins, quarters, and pennies only. Dante has 55 cents. How many of each coin does he have? Now, a lot of you guys, when you start talking about money, you're like, all right, let me draw a big quarter right here and say it's 25 cents. And then we could keep on doing all that stuff, but we don't need to do that. What I'm telling you now is that with a value problem, we can treat it the exact same way as we have every other problem. Let's let Q equal quarters. So if that is my first variable, if I'm defining my variables, what's my second variable going to be? Yes, it's going to be the pennies. What letter would you like to use, Jeff Stoops? P. Do you have an equation that you could possibly use for how many coins he has? Just the total number of coins, not even worried about how much they're worth, right? You say it has to be 7.
So Q plus P equals 7.
Exactly. That's the same problem that you've been doing. We say the sum of 2 numbers is blank. The total amount of coins is 7. Okay? Does that make sense, Jack? It does. I just really hate story problems, Miss Somerville. One of these days I'm just get over it, but not yet. Not today. Probably tomorrow. You know. So Q plus P equals 7, but then we talk about money. If I'm talking about 55 cents, how am I supposed to get cents when all I'm talking about is quarters and pennies? Any ideas? 55 equals, I love that idea. I'm going to put the 55 way over here, though. Q plus P. Interesting. Let me break this down to you. This would be your first coin, right? Coin number 1. This would be coin number 2. This would be the total. So if I want to talk about the money, wouldn't it make sense to have the total value line up with the total number of coins? Because it sounds like if we line it up, if we match up the value and the number, the value and the amount that you have just counted, then we could do an elimination problem. All value problems are going to be elimination. We just need to set it up correctly. How much is a quarter worth? 25Q. How much is a penny worth? has to be a total of 55 cents. Okay? So we can solve this pretty straightforward using elimination. And we will actually go through and solve it in a minute on the next example. But right now, the big idea for any problem that has value, any problem that associates a value with whatever we're counting. So anytime there's money involved, we set up two equations. Equation number 1 is called the count. Equation number 2 is always going to be the value equation. And we just stack the variables. Question so far? It's really easy when we talk about money, right? So we could talk about something like WinFo tickets. That's a big deal right now, right? Some of y'all going to WinFo on Saturday. Some of y'all asked some people to WinFo. I'm staring at one of you in particular because I heard about your ask. It was so cute.
What?
Huh?
What?
What?
How was it cute?
I don't know. I didn't actually hear about it. I just heard who. All right, so we got equation 1, equation 2. The first one's got to be the count. The second one's got to be the value. We need to make sure that we stack the variables up. Why are you making a big X in front of your face?
I was gonna do something, but never mind. What were you? Nothing.
All right, here we go. Child tickets. Cost 75 cents. Wait, no, I don't want to do 75 cents. Let's change that. Let's do $3. Adult tickets cost $7. And then I'll say something like, there are a total of 50 people. I know. And the total income is $310. How many kids are there? Everybody's just giving me these blank stares. A lot of people trying to avoid eye contact, so I don't call on them first. Kim!
Let children, let's see, let adults, wait, no, I did that right, did I? Let adults equals A.
Perfect. Hopefully you guys can hear that on the video right now, but what she said is that let A equal adults and let C equal children.
And then,
Equation number 1 is supposed to involve what?
$3.
Mm-mm.
Oh, no, wait, no. Equation number 1 is going to be A plus B equals 310.
Perfect. Not quite. Let's just count the people.
50.
A plus C equals 50. We're just counting people and only counting people. Now we want to talk about money. Jillian, how much is it for an adult to go to the show?
750. What?
Just $7, right?
It's like 750 because of 50.
Oh, wait, yeah, sorry.
So we put the 7 next to the A. How much is it for a child to go to the show? $3. So attach the 3 to the C. How much money is it? 310. So again, what we just said is that we want to stack our variables with each other. A's go with A's, C's go with C's. Total number of people goes with the total amount of money. Cool? Yes, ma'am.
Each of these problems, unless it includes like the one that right before you do, it includes each time that you solve it, each time you're gonna have to multiply by negative.
A lot of times you will have to multiply it by a negative. So what would you multiply it by? Let's go ahead and actually solve this one.
The first one by -1.
First one by
-3.
There we go. -3. So if you multiply the entire first equation by -3, we are solving by elimination. That gives you -3a plus -3c equals -150. 7a plus 3c equals 310. Has stayed exactly the same. What do you notice about the 3 c's? Oh, I don't know about those 3 c's. I'm going with 4a equals 160. That's what I'm thinking. Remember, this is elimination. We said that if you can get the coefficient to match, one of them is positive, one of them is negative, they will cancel each other out.
So on the quiz, is it going to be all elimination, or is it going to be different?
I'm going to mix everything together on your quiz.
Okay, so whenever it's like that, it's going to be elimination?
Yep, just like on your last test.
Just like on the test, okay.
Mhm. Yes, sir.
These are the kind of the format.
Yep. The format for your quiz tomorrow, just like we talked about before I started recording, you're going to have 4 problems where you need to set it up. You're going to have 2 problems where you have to set it up and tell me what you're going to do to solve it, like we did the first one. But then the last 3 problems, I'm going to say you need to set these up and solve them. I will include at least one value problem in that group. A is 40 and C is 10.
You have 5 subscribers on your YouTube channel.
Yeah, man, I got 5 subscribers on the YouTube channel. 6, my man Jack Smith just followed me.
Dislikes all videos.
Dislikes all videos. Yes, sir.
Oh yeah, on the quiz, will they all be count and value questions?
No. Some of them will be like we did last week.
What's the -3?
So we multiplied times -3 in the very bright green so that we could cancel out the 3c.
Oh, okay.
All right, last problem. We're just going to try to get it set up really quick. I'm going to pause the video for all of you listening on your own right now, just because I'm running out of time and space.
Hi, Mom.
All right, so while the video was paused a second ago, we went ahead and wrote out the entire last question that we're going to be working on. Jillian's in the back row, and she has 22 coins. She has nickels and dimes only. She has $1.55 in her change purse right now. And how many of each coin is that going to be? I'm going to skip the define the variable stage because I think everybody is comfortable with that part. How many coins is it total? That is what we need to be counting. Your first equation, William, what do you think?
She has 22 coins total.
Correct. So the question was, she has 22 coins total. That's for sure. That means it equals 22.
Alright, so it would be a plus between, say, like A and B or something like that.
We could go A and B. Let's go ahead and keep it simple. N and D. N for nickels, D for dimes. Got about 30 seconds left in the video, so we need to make sure that we can set up the last part. What is the value of a nickel? And the value of a dime? 5N, 10D. Equals. Now, here's my last part of the question. Could you do 1.55? You could, but if you have 5 cents and 10 cents, let's turn the money, the dollars, into cents. Let's get rid of the decimal, 155. Okay? Solvable? Yes.